Okay, trig derivatives. I know that you have been just so excited for this video. You have to know how to take the derivative of trigonometric functions, and usually that will include the chain rule. So this first problem, we have y equals sine squared x. If you need to rewrite it, this is how it's going to be given, but you can also rewrite this as sine x squared. So our outside function is the squared. Our inside function is sine. So to take the derivative of this, we need to follow the chain rule. To follow the chain rule, we bring the 2 down. We leave sine x alone. And then we subtract 1 from the power. So we'll leave a power of 1. Okay? Then we multiply by the derivative of the inner. So we did d outer, we need to do d inner. The derivative of sine is cosine x. So to simplify this, we can write it all in one line as 2 sine x cosine x. It does not matter what order you write the sine and cosine. This next one, we have a couple different things going on. If you need to rewrite it to see what's going on, you can. So we can rewrite this as cosine of x squared all cubed. So we're going to have a couple different chain rules in this one. You need to just take the derivative until you have taken the derivative of everything. So d outer, d inner. Let's take the derivative. The outermost function is the cubed. So we bring cube down, we leave everything on the inside alone, and we subtract 1. So we have a squared on the outside. Times, we need the derivative of cosine x squared. Again, that's a d outer, d inner. The outermost there is cosine. The derivative of cosine is negative sine of x squared. We leave that alone. Finally, the last derivative we need to take is of that x squared. So we multiply by the derivative of x squared, which is 2x. To combine all these into one nice pretty line, we can write this as a negative, from the negative here, 6x. We have a sine of x squared, and then we have a cosine squared of x squared. And that's how we would write our final answer, because we had a squared here and a squared here. This squared went there on the cosine, okay? And the other squared stayed with x. Another example we have is y equals 3 tangent x squared. So we have a couple things going on. To take the derivative, the 3 is a number multiplied in front, so it will just stay multiplied in front. So we do the chain rule. The outer is 3 tangent, the inner is x squared. D outer, d inner. The derivative of 3 tangent is 3 secant squared. This was x squared, so I have to write x squared. D inner, the derivative of x squared is 2x. So we can write our final answer as 6x secant squared of x squared. Finally, our last example is a product rule. So you have to be careful. We have 4 secant x times sine of 3x. Our product rule is first d second plus second d first. So we write the first to take our derivative. The first is 4 secant x times the derivative of the second. So the derivative of the second is a chain rule because we have 3x on the inside. So we have cosine 3x times 3 plus the second. We leave that second one alone. So sine of 3x, whatever we took the derivative of in the first one, we don't in the second one. then we do need to multiply by the derivative of the first. The derivative of 4 secant x, no chain rule necessary, no other product rule necessary, is 4 secant x tangent x. And finally, we can write that together. We will have 4 times 3, so we have 12 secant x cosine 3x plus 4 sine of 3x secant x tangent x. Yes, that is a long answer, but that is our answer.